Good evening, ladies and gentlemen. This is Khazar University's Mechanical Engineering Design class number 4. Today we will work on the design of oil mixer. Oil mixer for oil production, automotive industry. Most important part of design engineering is to get the technical specifications. You have to get into the job, you have to go to the place, see the needs of the customer, understand the environment. You cannot just sit at your desk and design it. You have to go, you have to see it, you have to feel it. So, technical specification. These are the main parameters. The main parameters of oil mixer. The value, our customer said 10 meters cubic. The temperature he wants to have is set from 5 degrees into 40 degrees. So we have to design a heat exchange system inside oil mixer so we can heat it from 5 degrees to 40 degrees. Time to heat, it's like he said competitors heat it in 2 hours. So in order to please the customer, we will do it in 40 minutes. That's my technological parameter. Time to mix, competitors mix in 2 hours. We will mix in 1 hour. Material, the customer said he doesn't care about the material. We will use S235 or Stal 3, the Russian material Stal 3. The reason for using Stal 3 is it's good against flammable hazardous, like flammable reagents, so it's good against burning. So the oil is flammable material, so this material will fit. And when you decide which material to use, you should always be aware of the market, what you have in your hands and what you can get from the market. So Stal 3 is the best material for Asian region. Best producer is Russia. Russia has the most production load in the world. So it's good to use Russian material for this design. However, we are not limited to Stal 3. We will use Stal 40X for shaft and blades. So the main important part as well is the material which is going to be mixed. So it's SAEW030, and this material has 2 points to consider: density and viscosity. So Main point is the density and viscosity at which temperature. We have to think about the worst case, and in this design, worst case is 5 degrees Celsius. So the point is the oil mixer is indoors. So your mixer is inside the building. However, the oil coming in comes from outside. The only way to know this is to go to that plant, look at it, and understand how it works. You have to understand the chemical procedure. So they have oil in reservoirs outside the building. Each reservoir is 60 meter cubic volume. There are 4 reservoirs, they fill them, and when they need to produce a quality oil, they transfer the oil from reservoir to the mixer, mix it with the reagents, with chemicals, in order to increase its quality and in order to produce SAE oil, and after mixing they send it back to the reservoir. The point is, you have to see this, you have to understand it. If you don't understand how system works, in your design you will face issues. This information is good for the start. However, when designing this kind of system, you will face a new parameters which you need to figure out. So you work on this system, you figure out those parameters such as rotation speed of the mixer, the blade type, the power of the motor. So you figure these things out, you consult with the customer, you approve it, and then you give it to the production. Then you give the shop drawings to the production. So point is, this is good for the start. Question is, what's the next step? What is competitor study? It's the moment when you look what your competitors did. You know, you don't have to invent a bicycle again, because inventing a bicycle has undergone 100 years of evolution, of developments, of improvements, advancements. You don't have to do it. You have to look at the current state and to add your own improvements, to add that extra 5%, 10% efficiency to it. So copy most of it. Copy means reverse engineer most of it, but add your own design as well. Add something that others didn't. Give it improvement. So point is, you have to be somewhere in between Edison and copying. So you should be here, because you are an engineer, you are not Edison, you are not a scientist. Point is, you are an engineer, you are not scientist. You have to do things fast and with results. So trying to invent something is time and money, and sometimes you may go wrong way and you may waste a lot of time and money and get nothing. So be realistic. Reverse engineer. Reverse engineer the thing. Add your own design. Add something. In this design, I will add new blade design and make a better blade for this design. So for your competitors, you will use China, Germany, Russia and UK. You may go Japan as well, but it's customary, so it it's good. It's good when you have China and Germany. The rest is customary. So first thing you have to look at your competitors' price. What's the price they offer? That's the first thing, because you have to understand what what you can build. So if you build it, will it be price competitive with others? So you have to figure out the price. You can go to Alibaba, write some email, write some message. I wanted the price of transportation to your. I have put down the technical parameters into Excel. The main reason is that we will need it when we will do the final report of this project. This is the map of all our work: design input, competitive study, materials, standards, engineering data, operation list, 3D model, 2D model, and at the end the report, the design output. We put all the data into Excel and Word files so we can use it at the end for the report. So, competitive study. For competitive study, we will work only on China. I have already done some analysis. The main point is using the right keywords for search. So, lubricant blending machine, 10,000 liters. 10,000 liters means 10 meter cubic volume capacity. So I have looked to all of them and I have decided to pick this one because it's has a range from 100 liters to 10,000 liters, where the limit is our one, 10 meter cubic one, and it's $11,000. We put $11,000 here. For shipment, we will charge it's $4,000. It's 2 ton equipment. It's $4,000 for shipment. For customs declaration, this equipment will cost around 15% of the total price. So total price would be $16,650. In Azerbaijani manats, it will be around 28,000 manats. So we already know our maximum cost, and we can now start our design and calculate our profit from it. I'm not gonna do Germany, UK, Russia analysis, but you can do it as your homework yourself. So my suggestion is to do Russian country analysis, because their equipment is competitive as the Chinese is, but Germany, UK, they are usually expensive, but of higher quality. And now we go to standards. There are lots of standards I will talk about, and I've already did some report, small report for our use, and these are the contents of the report. Standards, motor cap, body, heat transfer, shaft, equipment test, and all this data in this report I took from standards and books. So let's have a look at the standards and books of information like fundamental information about mixers. Like there's a motor at the top, there are blades which rotate the fluid and mix the compounds together. There are information about blade types. This is anchor blade. It's used for highly viscous fluids like honey, for example. There are different types of impellers which are shown here. This type turbine impeller, for instance, the blade shapes parabolic pitched. This book is very good for general understanding of the mixing mixing methods. So this this screw mixer. So there are also formulas which I used. This is the Reynolds number. For instance, I have put the Reynolds number calculation here, so that I took this formula, and our Reynolds number is around 43,000, and it's turbulent mixing since it's above 20,000. So turbulent mixing which means good for us, because when it's turbulent it means it will mix faster. There are also other numbers which have to be considered. I also input them in Excel calculation. And apart from it, there's also a good design suggestions. So this is the top view of the oil mixer, and they suggest to use two beams on it, where two beams for placing the motor. So the point of using two beams is to reduce the vibrations and to ensure solid work of the equipment. And as you see, they gave the span dimension like 15% of tank diameter. They gave the full information about it, and they also showed the side section view how to install it. And yeah, this is good because you don't have to spend your time on designing the motor mount, because it's already done for you. It's done by others, and you can spend your time on designing the blades, and you can invest in making better efficient blade which will use less power and give the same output. There are various mixing methods, so liquid solid, immiscible liquids. In our case, it's liquid solid, suspension dissolving. So there are test panning, there are lots of other criteria to consider. So this book and these are the main formulas and their abbreviations. Power number, very important. This is the power number. We need power number in order to calculate the power required for the motor. And in my calculations, it's 5.5 kilowatt motor. So
in order so it would be good if you do your calculations yourself. So you just input these parameters in Excel and get your power number. And if you find any questions, you can always send me email and ask it. I will always guide you and give you feedback. So they also put System International Metric Units as well, torque calculations from the power. You find the torque of your equipment, mixing speed, and there are also other considerations like the power unit per volume. It's used to look to the range if it's highly mixing, low mixing. There are the main one of the main parts is natural frequency calculation. I did it as well. So if if you make the calculations for natural frequency, you will be sure that your RPM, your turning speed, is normal. We will go into detail later about it. Now I go to the next one. So this is a Russian standard. The good thing about Russian standards is that they are free of charge. So point is, in Soviet Union, these standards, people were paid to create these standards. So if you were a professor and you did some research uh, on some design parameters. If you did research on, let's say, designing a shaft, so you gave your parameters like shaft must be this material, must be this length. If this length, then it should be this thickness, this diameter. And if you did this and you proved your research to be true by experimental data, you were given like money for that. You were earning money for doing it, and people were prone to do it. So they created a large amount of standards, and all those standards are free to public. Nowadays, it's the opposite way. So, in order to create a standard, you have to pay money. So, you want your standard to be publicized, you have to pay money so your standards get publicized. So, nowadays things are reversed than it was before. Yeah, it's really, really interesting to see that way. So, my suggestion is learn some Russian and use Russian standards, because English standards, they are not for free. You have to pay for them, and usually companies do not pay for them and they avoid buying standards. Only big companies can afford the standards, so Russian standards are the best way to go. This standard is about bend pipes. So it gives the technological parameters like the how rough the surface should be, the angles, the thicknesses, and other parameters. So dn is diameter nominal, the inside diameter of the pipe. So d is the outer diameter, t is thickness, and wait, t is yeah, T is thickness, and there are also other parameters. Also, weight of it is given here. So I needed this standard just to. So using these parameters, I I was looking for it just to make a breathing unit for the mixer so it can breathe air. So I just take DN100 and all these dimensions for my drawing so I can use it. So that's it about this standard. Next standard would be it's about general equipments, yeah, general equipments like mixers, like beton mixers, like potable water storage. So it gives information about the material to be used, the temperatures, the standards. So this, for example, is the bottom of the oil mixer. So there are a variety of design suggestions. So you can weld to, you can use a full metal sheet, or you can weld it at this part, or you can weld it at two parts. So you can use variety of methods, but you shouldn't go away from these methods. You shouldn't do something different. Let's have a look first. So here is the welding method shown from thicker material to less thicker material. There are also, let's see. So this is the material specification. So they allow you to use stall tree only if it's not less than minus 30 degrees. If it's less than minus 30 degrees, then you have to use other materials. However, in Azerbaijan, the weather conditions are never less than 30 degrees, so stall tree is totally fine for our design. There are also other variety of other information in this standard, and also they give the wall thickness parameter as well. And one of the main benefit of the standard is the wall thickness formula which they gave here. So if your diameter, take your diameter, divide by 1000 plus 2.5, that's your wall thickness. And in our design, our diameter will be 2500 millimeters, which was decided by our customer. So we just take this number, divide by 1000 and plus 2.5 millimeters, and we get 5 millimeter wall thickness. So 2.5 millimeter is the corrosion for corrosion resistance, and 5 millimeter is a perfect result for us. So we don't have to think about thickness formulas. We don't have to calculate them since we took it from OST 26 291 standard, and if some issues occur in the future, we will refer to the standard and we will show that we use this standard. So it's not our fault, it's maybe material failure or it may be welding failure, but it's the standard procedure, so we are on a safe line. This is all about this standard. I'll send it as well so you can have a look. And this standard is about the caps of the bearings. So these are three different types of the caps. First type is blind cap, second type is like extended cap, third one is double extended cap. So for different diameter bearings, different dimensions of the cap. Also the machining criteria for the cap are also given, like 2.5 roughness criteria. And yeah, this material we would use for closing the bearings and keeping them clean and safe from the outer environment. Next standard would be blades. So blades are standardized by Soviet Union, and as you see there are a variety of diameters. So if we go to my report, we can find out that the blade diameter can be taken from this information. This is taken from internet, the standard tank configuration. So there's blade diameter, height of the blade diameter from the bottom, tank height, and other information. So blade diameter is usually one third of the tank diameter. So information is given here for all the variety of blades, and we will look at the blade designs. And in our design we will use pitch blade, which would be the first one. This one would be our blade design. We will take 1250, half of the diameter will be our blade diameter. Blade diameter, tank diameter, wall thickness. So 1250, and from this we get all the other parameters like the this S, the thickness, it should be around 10 millimeters, the B, and this D, the shaft diameter, which has to be at least 80, and with H9 tolerance. So this standard we will use for blade design. However, we will not use pitch blade, we will use a cambered blade. And about that I will talk later. Then we go to the standard of mixing equipment standard, and here you can have information about like dimensions, like inner diameters. So 10 meter cubic usually inner diameter is 2.2 meters, and height is around 3 meters or 4 meters. It depends on the type you use, and there are around 9 types. In our case, we will use type 4. So the main reason for using type 4 is the top side is easier to design. It's easier to operate with this top design. So you can walk on the top of it and you can do your operations. And for bottom side, it's mandatory to be round. So the mixing procedure goes in forced turbulent regime. What I mean by forced turbulent regime, I will explain it now. Yeah, you are doing some on whiteboard, you explain it now. So as you see, they use a metal sheet. They cut it, the metal sheet on plasma cutter. They put it on this machine, which is which is a press machine, and they they start to bending it to proper dimensions they need. So I'll skip it a little bit. So as you see, it starts bending it. And if you choose less than 10 millimeters thickness for the material, it will not be as qualitative as it seems. So it will not be like fabricated. It will not be a product to be used. So highly suggested 10 millimeter, at least 10 millimeter thickness for the plate. So as you see, it starts bending it, and yeah. So after bending, they do this kind of further bending and double-sided bending, and this is the final result. This is the final bended yeah, it's the final bend. So as you saw, they bended it, so you have an idea about the process. So 10 millimeter at least. And it also gives the weight, how much it will weigh. It will weigh 136 kilograms. It gives the volume and other stuff as well. So I suggest when you perform it, you should leave at least, let's say, the H1, yeah, this H1, you should leave some space for welding. Yeah, H1 is, I think it's 40 millimeters. Let's look. 400 millimeters, huh? It's around 300 millimeters, but it's better to leave 400 millimeters for welding and also to make it normalized. And the point is, when you do this, you face production issues about which I will talk later. Actually, I can't tell it now. So
The problem I faced in production was that the guys who were generating bottom part, the bottom part of the oil mixer, they generated it like this. So this height was higher than this height. There were irregularities, and it caused problem for the welding engineers in order to weld the upper part, the upper cylinder. So these things happen in production. You cannot avoid them. All you can do is create a fixture with which you can cut the bottom of the system from this part, and by cutting it you would get rid of the irregularities, and then you can weld the cylinder to the bottom part of the oil mixer. So that was the problem we faced during the production.
next standard is standard about materials, Staltry material, and its nomenclature, that its explanations about which how it's produced, how it can be used. Everything is given here. It's tensile strengths, the yield strengths, and other parameters as well. Like so, main standard, the welding standard, hand welding standard. So there are variety of welding types: sheet face-to-face welding. So each welding type has its own name on the right side, which has to be shown in the sheet, in the shop drawing. So you just find your welding type and just select and look at the dimensions given here and input them in your shop drawings, and also write notes about how to weld it. So let's take as an example, let's take simple this one, yeah. So this is the length, the thickness. Thicknesses has to be equal, as you see here. By standard, they should be equal thicknesses. The distance between them must be at least 2 millimeters plus minus 1 or 2. The angle should be 45 degrees. So here given other information. So for instance, this one also, we will come back to this welding standard later, and we will use it when we draw the drawings. Okay. Next standard is about coupling. Coupling the pipes. So there are lots of coupling methods, and I will explain it while drawing because it's not explainable by looking. Legs, it means the legs of the equipment, and yeah, it's also standardized. I'll also show it while drawing. Next standard is about the pipes. So pipe standard, like the diameters, like lengths and stuff like that. So outer diameter, wall thickness, as you see, for let's say for 102 millimeter outer diameter, there is no wall thickness of 1.6 millimeter. It at least starts at 1.8 or 2. So it gives clear information about the wall thicknesses and pipe diameters, and you can use it for standardization of your design. So let's say you used 155 millimeter outer diameter and you draw your shop drawing, and tomorrow they are not able to find a pipe 155 millimeter of outer diameter, and they figure out that it's not standard for the bazaar, for the supply chain. So they found out that it's not standard, it's not in the sales, so they will blame you because you did non-standard design. So you should use this standard to overcome those kind of issues, to not face this kind of problems. Next standard is about welding the pipes. So how to weld pipes, different in different conditions, different methods. So it's also needed in order to show the welder how you want it to be performed. This is the book about mechanical design of mixing equipment. It has some formulas and suggestions as well, so you can have a look if you have free time. This book is about, this standard is about the metal, the shredder, we call it shredder, yeah, shredder that we will use for our design. So this is also good standard. So this one is the standard for the key for the shaft. So you can get the dimensions of the key. And this standard is about tolerances. So tolerances for fittings, which I will talk later while designing. And this standard is about the lifting part of the equipment. So you also have the design for the lifting lock. You call it lock. So you just come to the lock part. You look at the this designation. So that's 16-ton lock. It should be thickness of 22 millimeters. Its length 345 millimeters. So its dimensions are given. You just put it on plasma. You cut it, and you have your lock. I think it's pretty much about the standards. And the next step is to do engineering data.
Engineering data. So before we further go by engineering data, I will tell you some dimensions that I have already derived for the further design. The inner diameter was given by a customer, so 2500 millimeters. The bottom part of the oil mixer we decided to make round. There is a reason for that, very important reason: turbulence, forced turbulence. So assume this is your mixer, and let's say you made a rectangular bottom mixer, and this is your real mix. So there are two mixers. You put your blade in both of them, and you start mixing procedure. In this shape, the fluid is moving like this. It rotates. It comes from the blade, go to this and rotates. So when it's circular shape, its rotation, its vortex, we call it vortex, yeah? The vortex generation is more forced, it's more natural, it's more easier. When you have like this shape, the vortex will be generated. True, it will be generated, but there will be small vortexes here which will be problematic. These parts will not get mixed, but here there are no such spots. So in this case, mixing is much more efficient. So bottom has to be circular. So that is the reason why we use circular bottom. The other advantage of circular bottom of this type of mixing is that even if your Reynolds number is lower than the turbulent one, you still generate vortexes, and you call it forced turbulence. So, and even at lower Reynolds number, you get the turbulent picture, the turbulent behavior. So you get the turbulence, and turbulence gives you higher mixing efficiency, faster mixing efficiency, faster mixing time. In order to start designing on CAD software, I'll give you general dimensions. So 2.5 meter is the inner diameter. The bottom part wall thickness we consider to be at least 10 millimeters. The wall thickness of the upper part, which we decided to be 2 meters, will be around 5 millimeters by the standard, the Russian standard we used. You divide the whole diameter by 1000 plus 2.5 millimeter, so 5 millimeter wall thickness. So that's the design for the upper side of the tank. And inside of the tank, there is also a blade, like the mixing blades. So blade diameter, I took it from the standards for the procedures. Blade diameter is half of the, like this is the blade, yeah, of the nominal diameter. So if it's 2.5 meters, it will be 1.25 meters for the blade. So there is a blade here. Its diameter will be 1.25, 1250 millimeters. And the height from the ground, from the bottom to the blade, must be half of the blade diameter. So the point is, if it's 1250 millimeters, the height, let's say height of the blade, the height of the blade will be around 625 millimeters. The main reason of putting blade close to the bottom is the fact that it should generate that vortex, yeah. So they put it in this place because it creates the biggest and the most powerful turbulent vortex by this way, by the half of the blade diameter. Let me ease for you this, better show the picture. This is the blade. So this is the blade, this is the blade height, blade diameter, there is a shaft connected to the motor. Apart from it, when picking the motor, I would pick a motor which would be 2 times more powerful than the required power. So in order to rotate this blade, you need power. Let's say you need 3000 watt power, yeah? I would pick 6000 watt motor. And picking double time the power of the motor is called classical approach. So you make sure that you will never get any motor defects, like motor out, motor burn, like overload in the motor and resulting in burning of the capacitor. You will never get such issues. So it's always better to get 2 times more powerful motor for these kind of designs. So we will start designing it. We will put 3 legs, and another point I would like to talk about is the ways, the cell loads, yeah. They put weights under the legs of this mixer. They put it in order to weigh the how much fluid is inside it. So we will also pick ways which we will use, and usually they put 3 legs for this kind of mixers. We will use 3 ways, and yeah, that's, I think, all. We will also design the upper part, this Schweller thing, and I think we will do it when we're designing. So that's all for now.